So hello everybody to the next GeoBoost video. Now we are talking about the ground source heat pump systems and part 3, and I want to tell you something about borehole heat exchangers today. So borehole heat exchangers is one of the most common solution for shallow geothermal energy. So the most installed system. It's a closed loop system, and how it looks like, you see it here on the left side, that we have pipes which carries a heat carrier fluid, and this is circulated in the underground in some pipes and collect here the heat to a specific depth, and then actually lead the heat to the heat exchanger system and to the heat pump, and then actually this circulation starts again. You have a specific temperature in the depths. If you go deeper, it's getting warmer. So a deep geothermal borehole heat exchanger can collect more heat than a shallow one. But of course, borehole heat exchangers can be used for single households, as you see it here, but also for larger buildings, like hotels, blocks, and so on, whatever you can think of. And then, of course, you have a borehole heat exchange fields, and you need a spacing between these the specific borehole heat exchangers, because, of course, some borehole heat exchanger is actually using the heat from the underground and it's cooling down in the heating season, and then it should not be influenced. The borehole heat exchangers should not influence each other. So, of course, in summertime, in the regeneration phase, actually, the heat comes back, and then you can actually heat in the next season again. So, but the distance must be there between the borehole heat exchangers, because otherwise you cool down the underground for the long term. A borehole heat exchanger can be designed quite very different. Normally, a standard one is a U-pipe system, so you have one pipe where you collect the heat, and then you go back to the pipe with a cooler heat carrier media, and then it's collected the heat again, and then you can use it again. But you have also the W pipe, so you have two of such connected pipes in one borehole. You can have also a coaxial pipe, so where you have the warm pipe inside and outside the cooler ones, so that you just need one pipe here, and cool can run here with a hotter inner circle and a cooler outer circle. This works also quite well. And then you see here how it looks like such a borehole heat exchanger pipe. And here you see also some construction. Here we have also centralizer, that these pipes are actually, centrally installed in the borehole. And here in the middle, you have such a pipe where you can cement the borehole back. So you see here in the backfilling of the borehole is then the grout. So a cementation, which has also a very good thermal conductivity. So this is how it looks like. Of course, what is important for borehole heat exchangers, this is the underground parameters, like what is the temperature of the underground, what is the thermal conductivity of the underground, and the heat storage capacity of the rocks. These are key parameters which should be assessed in the planning phase of such a borehole heat exchanger. You can measure it with specific measurement devices, and this should be done before. Also, groundwater conditions should be considered, because groundwater are quite favorable for borehole heat exchange installations. Groundwater actually carries the heat back to the borehole heat exchanger, so it's quite favorable to have also groundwater conditions, good groundwater conditions. What is also important is to see that the temperature constraints and the thermal load of the house determines the required length of the borehole heat exchanger. So the underground parameters, but also how much heat is needed to heat the house. This actually controls how deep we should drill a borehole heat exchanger. So we have to drill the borehole heat exchanger as deep as we need it to cover the heat demand of the house, of course. So it is important to know what is the heat demand of such consumer. So temperature distribution of the heat demand, peak loads, and so on. Temperature limits must be known also for the characteristics of the heat pump. And then the ratio between the thermal load and the length of the borehole heat installed. This is actually crucial. So along with other factors like numbers and distance of boreholes, of course. So if we have a huge thermal load, then we have to drill a few more borehole heat exchangers, or you can also say we have in some we have to have a longer distance of a drilling distance or drilling meters to fulfill then the heat demand. So this is also some factors to determine the thermal alteration of the ground and hence the temperature of the heat carrier fluid. So it actually shows also how the temperature goes down in the underground during the heating period and then how it's recovered after the summertime again. So what is also important is hydraulic constructions of the geothermal cycle, so of the cycles, what is the pressure loss, how the heat carrier fluid behaves in the pipes, what do we need for the circulation pump and so on. This must be also very well designed. Of course, you can use borehole heat exchangers also as a storage system, a so-called beta system. So this is quite like an ATES, just in a closed loop system. So you have also a charging and a discharging, which means you charge, you put heat in the underground with the borehole heat exchangers, and then you can use it during winter time and actually discharge it. Such borehole heat exchangers have specific designs. Normally, you have here a warmer inner core and a colder outer, cold boundary, have to say. So you have to see also how we design such a beta system. So here you see a lot more. This is one example that we have a solar park here, a lot of solar panels installed, and this actually they produce heat in summertime. This is stored in such a borehole seasonal thermal storage, and then you can actually use that for heating the house in wintertime. Such a borehole thermal energy storage has to have a specific design. So, for example, you have a top heat losses, so you need insulation here normally, and also the spacing of the borehole heat exchangers for such a beta system is very important and a lot more. So you have to design it very carefully that it will be efficient, but it's a very good way for heat storage.